Good morning. This is Ibrahim once again. I want to show what I just worked on, which is a fuzzy logic system that has to do with two inputs and one output. And this is done with MATLAB under the fuzzy logic designer. So this is the final result. So this video is going to be short. I'll just try to run through some of the key things. So this fuzzy logic inference system, which means FIS in short, it has different parts. So the two key inputs are the temperature and the humidity. And basically this inference system is to be able to control an air condition system. So the output variable is the cooling power. And the way fuzzy logic works is that you take physical input, it has a falsifier which uses a membership function to be able to create a fuzzy set, and that falsifier goes into the inference system, which is also connected to the rule-based system, and with that it creates fuzzy output. Then that goes into the falsifier, which kinds of break it down into the normal output that can be used. So that's more like a rundown of how a fuzzy system works. So in this particular case, we have the input, which is the temperature, which has been configured. To show you how it's being configured, well, let's say I click on it here. You can see this is the temperature. So it has three states. So you have the cold state, the warm state, and the hot state, which I configured based on the configuration here. And for the shape in here, I use trapezoidal. So for the inputs, I could have used other shapes like sigmoid, which is sigmoid, Gaussian, other triangular, but I decided to use trapezoidal here for the first one. Then the range for the temperature is between 10 degrees to 40 degrees, and it spans between the cold, the warm, and the hot state. Let me show the other one, which is the humidity. The humidity is also another input that goes into the fuzzy system. So it has dry, comfortable, and humid, and the range is between 20 to 90. I also use trapezoidal for this also. Then the output itself is the cooling power, like I said. So here it is. So for that I use triangular shape. It has three levels also. We have the low, the medium, and the high. So the range is between 0 to 100 for the cooling power. So the rules here, there are three major rules which I use to configure this Fuzzy inference system. So here we are. So here are the rules. Let me just try to see if I can zoom them. So here are the rules. For example, if temperature is cold and humidity is dry, then cooling power is low. That's rule number one. Then if temperature is warm and humidity is comfortable, then cooling power is medium. That's our rule number two. If temperature is hot and humidity is humid, then cooling power is high. That's rule number three. These are the rules that I am using to govern this particular system. So I have configured them here. So when I click on this, for example, I have access to the rules. I can edit them, add more to it, but I won't do much about the rules anymore because the three rules kind of work perfectly. I just want to show that it works, and I want to show the result using three different, maybe two, let's say just two different systems. So the first system will be the rule inference, and the second system will be the control surface inference. So for me, if I decide to show the rule inference system, let me try to click on that here. This is the rule inference system. Based on the rules I've set for the two inputs, we have the temperature on the left hand side, we have the humidity on the right hand side, and we can see how it behaves for the cooling power on the right hand side. So at temperature of 25 degrees and humidity of 55 degrees, and the hand function for the which is also the minimum kind of rule, the cooling power is about 50. Then for the other side, which is 25, humidity power and the hand rule for the minimum, we can see the graph here. For the OR case, we can see the graph also, and we can see how everything aligns at the center in here. So this is a very good result that shows how the inference system, Fuzzy inference system works. Then that's on one side. On the other side, I can decide to use the control surface to be able to show the result of this same inference system. So let's say I decide to click on the Fuzzy control surface here. Here is what I will have. I will have a 3D surface plot whereby I have humidity on the X, temperature on the Y, and the cooling power on the Z axis. And you can see how everything spans here. So we have, for example, it means that if I pick a point, you can really see what is going on. So on the X, we have 12.124. So when temperature is 12.12 and humidity is 70, I can really see what the cooling power will be. And this inference system tells me the state of this system at a individual point in time. So, and this visualization allows us to be able to see how this Fuzzy system is behaving. And then why we need Fuzzy system is because there are states whereby the system behaves in a way that is not certain. And for a Fuzzy system works based on rules and membership function for the falsifier to be able to get required behavior for the particular system. So this is one thing that is very important about Fuzzy system. And with this visualization, you can basically see how the result is going to look like. So here we have, I can decide to play around here just to show different states, different behaviors. So can we see at this point? So when X is 29, Y is 55, Z is 50. So X, Y, Z represents the temperature, humidity, and what? The cooling power altogether. So I think that's all, and that's all captures what we have here in the Fuzzy inference system. So I can also decide to play around with this Fuzzy inference system, for example, from the command line, whereby I can decide to export this Fuzzy inference system. For example, I can decide to export it into, so this is for FIS, right? I can decide to export it. Okay, I think I already exported it before, but let me just export existing override it. Yes, export anyway. So I want it to override the one I have before now. So let me see if I can show you what I have. Okay, good. Okay, let me see. So these are other simulations. Well, let me just close this. So here we are. So what we have here is like from command line, I can decide to play around with this Fuzzy inference system. So by exporting it here, can you see I already have it in my workspace, which is the FIS Fuzzy inference system that which I already exported to workspace. So from this Fuzzy inference system, I can, for example, demand for answers, for example. So in this case, cooling power, which is what I want to know. I can say evaluate Fuzzy inference system, right? Which is going to take the Fuzzy inference system here as an argument, and it's going to take what I want. So what I want is at 25 for temperature and 55 for humidity. I want to understand what's going on, right? So let's say, can you see cooling power is 50. So from command line, I'm interacting with my Fuzzy inference system, which I've built. So for example, I can also go as to say, for example, cooling power, right, equals to, let's say, let me decide to use evaluate Fuzzy inference system at, okay, the Fuzzy inference system at, let's me just use 35 by let's say 60. Remember, I can't use something that is beyond the range. So the range for the temperature is between 10 to 40, and then so because of that, I can't use any range beyond that is more than 40. So let's say this is what I want to test, right? I think I'm good to go. Yes, I think I'm good to go. So can you see cooling power is 80? So this works, and this shows that the cooling inference system works. So for example, I can also go back to what I've tested in here. I can go back to the for example, the Fuzzy Inference System here. So for the rule editor, so think the rule inference, okay, good. So at 25, 55, we got the cooling power to be 50. Let's say I decide to change to 35. Sorry, 35, 35 by, what did I use the other time? Let me check. Okay, just to be sure. On the command line, 35 by 60. So 35 by 60. Here we are. So can you see cooling power equals to 80? So what I can do on the editor here, I can also do on the command line, and that's basically the whole inference system. So this is more like a mini space where you can easily see all the integral parts of the Fuzzy Inference System, and you can edit them. So and this is why MATLAB is very good. It allows you to be able to build this and visualize this. And in this particular case, I'm using Mamdani as my type for the rule-based system. So can you see this is temperature again? This is humidity. I think I've showed this earlier. These are the inputs, right? These are the outputs, cooling power. And if you come back here, for example, let's say you are working on like this is more like a MISO, multiple input, single output system. It's possible that the kind of system you have to deal with is maybe a multiple inputs, multiple output system. You can basically come in here and add in more inputs. So it's that simple. It's not a big deal. You can, for example, add more inputs to this. So you can add more inputs to this. Just from here, you can add more inputs. So it's not a big deal at all. So yeah, here from more inputs, you can add more inputs. So you can see from inputs here, you can add more inputs. Can you see? I have one extra input added to this, and I can start working on it as input. I can name it anything, but for this I don't want to tamper with this kind of system because I'll have to change the rules to accommodate these new inputs if I want to go that route. So I can also delete this particular input. So after deleting it, I have what I already have before. So in short, a physics system is a very good way to design system, especially when you are dealing with things that overlap and you need that works with the rules, and you think a physics systems will be the best approach towards solving it. And based on if you have a well-defined physics system, you can easily implement it inside MATLAB. And I, as a MATLAB ambassador and with my knowledge of Fuzzy Inference System, I am creating this video to be able to put all of this together to show that designing Fuzzy logic system is possible with MATLAB, and it's kind of very easier, and you can also visualize the results, and you can build much sophisticated system with this if you have time to play around with it. So that's all for now. I remain Ibrahim Badegeshi. Thank you very much. Bye.